Welcome to the first part of a new series that I'm starting called CSS Mastery. This will be a series where I take a deep dive into specific CSS topics, and our goal will be to hopefully be an expert on the topic having watched the video. Now, these videos won't be like the other Intro to Topic X videos you find elsewhere, where they give you a surface level knowledge on a given topic. But instead, what we'll be doing different here is that we will be going very in depth with all the intricacies and the rules associated with a given topic. So if that's the type of content you're looking for, please click like and subscribe to my channel for more videos like this one. Anyways, today's topic will be on the position CSS property. So let's get started. So let's first start off going over why we should have a deep dive into the position property in the first place. All right, so first of all, if you're dealing with HTML and CSS, you will be using this property all the time. Now that's pretty obvious. But the reason why I'm starting off this series with the position property is because it's one of those topics where on the surface it looks pretty simple and straightforward, but when you start using them in real life applications, they can very easily get out of hand. Whether you are a junior developer or a veteran in front-end development, I think everyone will still run into problems with the position property from time to time. One of the things that makes it tricky is that it may not be so clear what the actual differences between each of the position types are. Another reason is that the associated CSS properties, the left property, the top property, the right and the bottom properties, these are often used in conjunction with the position property, by the way. So these behave radically different depending on which position type you're using. So for example, the top property for an absolutely positioned element will be very different from a top property for a sticky positioned element. Now you would think that these would behave identical regardless of which position type you use, but that's not the case. And finally, and this may not be a completely separate point compared to the rest, but there are a lot of weird niche rules that comes with the position property. So if you don't know about these rules, it may throw you off and you may run into problems with it in the future. Okay, so first of all, what does a position property do? It determines how the associated HTML element is positioned in a document. In other words, we can position an element any way we want on the page by using this property. Now to use it, just add the position property in the CSS to any HTML element. In the picture I posted here, I'm putting it on a div with the class name box. So it's pretty straightforward. Now there are 5 types of positions you can choose from, and they are the static position, the relative position, the absolute position, the fixed position, and the sticky position type. The static type is the default type, so if you don't explicitly write what position property an element has, it will default to the static position. We're going to be studying each type in detail very soon, but before we do that, I want to make a quick distinction that will make it easier for us to understand how certain rules are applied. We are going to be partitioning the 5 position types into 2 separate categories. More specifically, we will be categorizing the HTML elements that has the position property into 2 separate categories: the positioned elements and the non-positioned elements. Now, the positioned elements are the elements that have one of the following types: a relative position, absolute position, fixed, and sticky. So pretty much all position types except the default static type, we call them positioned elements. And of course, on the non-position element, we have just the one type, the static type. So these are the 2 distinctions. So why am I making this distinction? First off, positioned elements, i.e. the elements using relative, absolute, fixed, or sticky position, they can use other position-based CSS properties, the left, the top, the right, bottom, and the z-index property. For an element whose type is static, these properties will have 0 effect. They will not do anything. Even if you put a left property on a statically typed element, it won't do anything. You can try using them, but nothing will change on the page. So again, positioned elements are named such because you can quote-unquote position them on the document with the various positioning properties. Statically positioned elements cannot. And also, and this is very important, the left, top, right, and bottom properties, which I will refer to them on this presentation as the LTRB properties, these act radically different depending on which position property you're using. We will study how they are different when we study each of the types. Let's start off with a static position. A statically positioned element is positioned with the normal flow of the document. So I'm going to be referring to the quote-unquote flow of the document often in this video. So let's get a clear understanding of what this means. If you're dealing with a block elements, for example, and you have, let's say, 3 divs with a certain height, the first div will be rendered at the top, and right below the first div will be the next one, and right below the next one will be the final div. This is what's called the normal flow of the document. If you are dealing with a flexbox container, then the elements will be positioned with respect to the flex rules you have set. And if you are dealing with a grid container, for example, then they will be positioned with the grid rules, etc., etc. So that's what we mean when we say that an element is positioned with the normal flow of the document. We are stressing this point because some position types will take the element out of the normal flow, so it's important to make that distinction. And again, the static type is the default value, so if you don't explicitly put a position property on an element, it will default to the static position. And as I said before, the left, top, right, bottom properties and the z-index property on a statically typed element will have absolutely zero effect. Let's see this in action. So I have my editor open on the left side and I have the preview open on the right side on the browser. And if you see my HTML, this is my HTML file, index.html. I have a parent class, a parent div with the 3 child divs inside that explicitly states what type of a div they are, child 1, child 2, and child 3. You can see this here. And I just gave it basic styling. I made a parent tomato orange. The child 1 is steel blue, child 2 is greenish color, and child 3 is this olive color. And notice I didn't give the position property to any of these childs. So as I said before, the default position property of all of these is static. So not writing any position property is the same thing as writing position static if you want it to be more explicit. If I refresh the page here, nothing changes. That's because statically typed is the default type. Now let me erase this. And what I said in the PowerPoint right before this was that the left, top, right, and bottom property has absolutely zero effect on a statically typed div. And let me show you guys that right now on an element I mean. So let me just try left is 50 pixels. I refresh the page, nothing changes. If I do left, maybe top of 50 pixels as well, I refresh the page, again, nothing changes. Now, just to prove the point that the z-index is also not affected, let me do this for real quick. I'm going to be talking about the other positions soon, but just to prove a point, let me introduce the absolute type right now. Again, I will explain it later. Let me make the parent. I will also introduce the relative type. I will make the parent a relative type. I will make maybe child 2 of position absolute, and I will give the left property of maybe 5. How about 10, 15 pixels? And maybe the top of also 15 pixels. And let's see what that turns out to be. So again, I'm putting the green child as absolutely positioned with the left 15 pixels and the top 15 pixels. I refresh the page, you could see that it is now on top of the child 1, who is statically typed. Remember, we tried to put a left and a top property on this one, it did nothing. But if we put a left and a top property on the child 2, let me just comment out the left here, you can see that it actually does stuff, right? So I'm going to refresh the page. Now, let me show you guys that the z-index on a statically typed element does nothing. Let me just put z-index of maybe 1 on child 2. Now, if child 1 was affected by the z-index, if I were to put z-index of 2 here, since 2 is greater than 1, we should see child 1 on top of child 2. However, if I save and I refresh the page, it does absolutely nothing. That's because, again, statically typed elements has no effect on the z-index. So the z-index does nothing to a statically typed element. This is a point of much confusion to many developers around the world. So please, let's learn from this. Statically typed elements is not affected by the z-index. nor is it affected by the left, top, right, and bottom properties. So again, this was the statically tight position. The next type we will talk about is the relative position. So the relative position, just like the static position we just seen, is first positioned within the normal flow of the document, but then it is offset relative to itself depending on the left, top, right, bottom properties that you assign onto the element. So just as an example, let's pretend we have three divs again, with the middle div, the green one, with position relative type. Now let's say we gave it a left property of 10 pixels and a top property of 10 pixels. Then it would be just offset from its initial position by those amounts without affecting any of the other elements who are following the normal flow of the document. This offset does not affect the position of any other sibling or parent elements. What I mean by this is the space reserved for the relatively positioned element is the exact same as the static type. It's almost as if the other elements have no idea that it is relatively positioned. The children elements, however, behave the usual way you would expect, and that is they are positioned relative to the parents of the new offset position. This is actually how most people will use the relative position. It is used most often to be the relative point to position one of the element's descendants that is a positioned element. Now, if that didn't make sense right now, it will once we get to the other types, so don't worry about it too much for now. But the final point, and this is just my opinion, but I think many would also agree with me, but I would advise against using the relative position to offset the element. What I mean by that is this. If you decide to give an element a relative position, don't also give it one of the left, top, right, bottom properties to offset it. Only use the relative position to relatively position one of its children or its descendants. Okay, so I'm back on my editor and I kind of reverted the changes we made before. So if we look, we have the parent div and we have the three child divs. So none of these have an explicit position, so they are all position static as default right now. Now what I want to do is for our child 2, which is this green one, let's give it a position of relative. If I refresh the page, nothing changes. So right now, without any offset properties like left, top, right, or bottom, it behaves exactly the same as a static property. However, now, if I give it a top property of 15 pixels, then it is offset from its original position 15 pixels down. Meaning 15 pixels from the top, you go down 15 pixels. And if we give a left property of 15 pixels, from the left side of its container, it will go 15 pixels to the right. So if I refresh the page, it went right. So now our child 2 is offset 15 pixels from the top and 15 pixels from the left. Now, something interesting is happening, and this is unique to the relative position. Look at child 3 and child 1. They were not affected by these offsets by the slightest. They are in the exact same position as they were before. So if you look at this child 3, he is in the same position as if the child 2 was in its original position. So a relatively positioned element takes the same amount of space that a statically positioned would. It is just offset from its original position by the amount that we have set, in this case top and the left property. Now, just to show you guys that the children of a relatively positioned, how the children behaves, let's go inside child 2, and I'm gonna put another div here. I'm gonna call this div class grandchild. I won't give it any text inside. Obviously, nothing is showing up because I didn't stylize it yet. Let me put a style to the grandchild. Maybe we will give a width of, what width should it give it? Should we give it a width of 50 pixels and a height of 50 pixels just to see it? And let's give a background color of maybe black. Let's see what we have. So notice, let me move the child 2 back to its original position by commenting this out. Look at where the grandchild is positioned, right? It's in its usual normal flow within child 2. Now, when we offset child 2, with the relative position. The child 1 and child 3, the siblings of child 2 is not affected, but its children, child 2's children, has moved along with the element that has just been offsetted. So this is the usual way of how a child or children of an element behaves. So I just want to show you guys a distinction between how they move depending on this. Now again, I'm going to say this again. This is my opinion, and it's the opinion of the most developers, I think. I would advise against using the offset properties of top, left, right, and bottom with the relative position. And the reason is because the siblings has no idea that he has been offset, right? So this makes it very difficult to style. It becomes hard to style this. So what's probably better is to use a different position property to position it the way that you want. Only use the relative position when you want to position a children element of the relatively positioned element in a special way. And that will become more clear once we talk about the next topic, which is the absolute position. The absolute position type is oftentimes used in conjunction with the relative position. An absolutely positioned element is removed from the normal document flow. No space is created for it in the page layout. And so the next sibling elements will take its place in the document flow. What this means is that to other non-children elements, it's as if the absolutely positioned element didn't even exist. This is the first position type we saw that takes the element out of the normal document flow. So how is it positioned? Using the left, top, right, bottom properties on an absolutely positioned element offsets it not with respect to where it should have been, but with respect to its closest positioned ancestor. Remember earlier when I made a distinction between a positioned element and a non-positioned element? The absolutely positioned element will look for its closest ancestor whose type is either relative, absolute, fixed, or sticky, and it will position it with respect to that element. Now, if it doesn't have any positioned ancestors, then it will position it with respect to the body. What if we don't use the left, top, right, bottom property on an absolutely positioned element? Then it will position it where it would have been normally, except that it is still taken out of the normal document flow. There's not much, if any, use case for this, however, so I would recommend you always use at least one of the left, top, right, bottom properties with an absolutely positioned element. I know what I've just said may be very confusing, so let's look at examples of what we have just discussed. All right, so I am back on my editor. I am back to its original position, kind of, where all the positions, the explicit positions, are taken off. So notice the parent, it doesn't have a position property, the childs don't have a position property, and the grandchild that we have made doesn't have a position property. These are all statically typed because the default is the static type. Now, what I want to do is let's give child 2 the absolute position. Position absolute. I'm going to refresh the page. Notice what happened. Child 2 doesn't seem to be affected at all by the position absolute. However, child 3 disappeared. So where child 3 is right now, it's actually right below child 2. So if we give the z index of -1 to child 2, it will place it behind the parent, and now child 3 exposed. You can see child 3. So this is back to what we were saying earlier, where the absolutely positioned element is taken out of the normal document flow. So therefore, child 3, according to child 3, child 2 doesn't even exist. So he has taken the place of where child 2 should have been. Now, because we didn't give, let me get rid of the z index actually. Let's refresh the page. Because child 2 wasn't given any left, top, right, or bottom property, it has just placed itself where it usually would have been if it didn't have a position absolute, meaning where it would have been if it was position static. But now the interesting thing happens when we give it a left and a top property. But I don't want to do that to the child 2 for now. Actually, do I want to? Let's start with the grandchild, which is an element within child 2. So I'm gonna make the grandchild have a position relative, absolute, and I refresh the page and nothing happens. But now let's see what happens if I give it a left property of maybe 15 pixels. I'm gonna refresh the page and look at where it is. So where is it with respect to 15 pixels from the left? So right now, because the grandchild doesn't have any positioned ancestors. Remember what we talked about, a positioned element is an element that is not statically typed. But if we look at all the ancestors of the grandchild, which is child 2, it is statically typed, and the parent, it is also statically typed. So because the grandchild doesn't have any positioned elements as its ancestor, it defaults to making it left from the body. Which is this whole thing. So if we were to also give it a top of 15 pixels, it will be left from the top left and top 15 pixels from the top. So you can see it up here. So let me get rid of that real quick. No, actually, I'll keep that in there. But now, if I wanted it to be left 15 pixels from child 2 and top 15 pixels from child 2, we can do something like this. We could make the child 2 one of the positioned elements, make it a position element by giving it either an absolute property, or in this case, I want to use the relative property. I refresh the page. Now the black div, the grandchild, the child of child 2, is positioned 15 pixels from the left and from the top. So let's see what happens now is, what if we wanted to, I'm gonna comment out these position absolute left and top from the grandchild, and let me refresh the page. I want to make the parent a position relative. I refresh the page, nothing really happened. And now, instead of making the child 2 position relative, I want to make it absolute. So now it has a positioned ancestor, which is the parent, is direct parent right here, because we gave it a position of relative. So if I were to go to child 2 and give it a top of 15 pixels and a left of 15 pixels, it should place it with respect to the parent element. So maybe around right here where child 1 is, on top of child 1. I refresh the page, I press the wrong button. I want to refresh the page, and that is where it ended up. So remember, child 3 took its position in the document flow, and child 2 is now positioned with respect to its closest positioned ancestor, which is the parent in this case. But now, if I also reintroduce the absolute position and the left and the top to the grandchild, what it would do is it would look for its position ancestor, which is child 2 in this case, because child 2 has a position of absolute, and then it will position itself left of 15 from child 2 and top from 15 pixels from child 2. Let's see that come to play. I'm going to save and refresh the page here. And now it is with respect to the child 2. If we were to remove the absolute position from child 2, and also, why don't we just remove these, although they don't really do anything because they don't affect statically typed. Now, child 2 is back where it should have been. And what the grandchild did is it looked for its closest position ancestor, which is the parent in this case, because its direct parent, which is child 2, is no longer a positioned element. And it has positioned itself, the grandchild has positioned itself with respect to the parent element. The next position type on our list is the fixed position. This type is very similar to the absolutely positioned element, except with a couple notable differences. So first off, just like the absolute position, the element is removed from the normal document flow. No space is created for it in the page layout. The sibling elements pretend that the fixed position element doesn't exist, so the next element in the flow takes its place. And just like the absolute position, if you don't specify any left, top, right, or bottom properties on a fixed positioned element, it renders itself where it would have been as if it were a static typed. Using the left, top, right, bottom properties, however, positions the element with respect to the viewport. Now, this is the first distinction between the fixed type and the absolute type. Remember, for an absolutely positioned element, it was positioned either with respect to one of its closest positioned ancestors or the body. But for a fixed position, it positions it with respect to the viewport. So for example, if we had a left of 15 pixels and a top of 15 pixels, it will be positioned from the top left corner of your browser by 15 pixels each. Now I put an asterisk here because there is a caveat to this, a very small detail that I didn't even know about until I was studying up for this video. If any of the element's ancestors have either a transform, a perspective or a filter property applied on it, then the fixed position element is no longer positioned with respect to the viewport, but rather the ancestor with one of these following properties becomes a new point of reference. Now, this is really weird, and I'm not sure what the exact reason for this is, to be honest, but I'm sure there was a good reason for this. But I think this is such a small, like a niche case for the most part. We can just think of a fixed position type to be with respect to the viewport. Now, one of the ramifications of this, especially compared to the similar absolute type, is that even when you scroll, the fixed element will stay in the same place, unaffected by the scroll. Let's now go and see this in action. Okay, so I'm back here on my editor, and let's go to child 2 and give it a position of fixed. I'm going to save, and let's see what that does when we don't apply anything to it. So again, child 2 is taken out of the normal document flow. So child 3 took its spot. It's hidden underneath it, and it's in the place where it should have been as if it were a static type. But now let's give a couple left top properties on it. Left 15 pixels, top 15 pixels. I refresh the page. It is left and top from the top. Now, if it were an absolutely positioned element, it would do the absolute same thing. I could show that to you by refreshing the page, changing it to absolute, and it's at the same place. But where this differs is this. For the absolute position, right now my child 2 is absolute. Let's go to our parent and give it a position of relative to make it a positioned element. Then if I refresh the page, now the child 2 is positioned with respect to the positioned parent, which is the parent class in this case. But if we change this now from an absolute type to a fixed type, I refresh the page, it has gone 15 pixels left at top from the viewport still. Now, I want to do something to see a little bit more of a comparison between the fixed and the absolute. So I'm going to go to my child 3, and this I will make it a position absolute, and the child 2 will remain as a position fixed. Let's give position absolute to the child 3. I'm going to give it a left, not of 15 pixels, but maybe 15 pixels. Is that enough? That might not be enough, but let's see. Top, I want to put it next to our child 2. Refresh the page. Yes. So I'm going to get rid of the relative position because right now child 3 is positioned with respect to the parent, who is a positioned element. But I want to get rid of this so that he is positioned now with respect to the body. All right. So child 2 is positioned with respect to the viewport right here, and child 3 is positioned with respect to the body. So where they differ, where the fixed position of child 2 and the absolute position of child 3 differs is when we start scrolling. So I'm going to scroll down. Notice child 3 went out of view, but child 2 is staying in place. So fixed position is fixed in place, is fixed in the viewport. But now let me show you guys the caveat that I was mentioning. So I'm going to get rid of the absolute position and the left and top from child 3. And child 2, notice, is still here, fixed from left to 15 pixels and top to 15 pixels. But now let's do something interesting. I am going to go to my parent and give it a transform property. Transform, and I will translate this in the X direction by 15 pixels. What this means is it's getting where it initially was rendered on the screen, this big orange thing right here, that's the parent, and it's gonna offset it to the right in the X direction by 15 pixels. So we should see this whole thing shifted to the right by 15 pixels. Remember what I said earlier, one of the caveats is normally a fixed position is always positioned with respect to the viewport, except when one of his parents ancestors have a transform, perspective, and a filter property. So let's see what happens now. I refresh the page, and now the child 2 is 15 pixels from left and top with respect to the parent element because the parent had the transform property. And even when I scroll, it's no longer fixed in place. It's actually fixed with respect to the parent now. So this is like a minor caveat that we got to worry about in a fixed position. But for the most part, I don't think most people will run into this issue. However, if you do run into this issue and you didn't know about this one caveat, that this will be a pain in the butt to try to fix and debug, but now we know. But anyways, a fixed position for the most part, it just fixes it with respect to the viewport like this. So you could do a lot of cool things like putting up a menu that no matter what, it will still stay on the top no matter how much you scroll. So this is a very handy position type. And the next type we're going to be looking at is the last one, and probably arguably the hardest type to fully understand, and that is the sticky type. The sticky position is very hard to understand through writing. It's probably better to see examples of it in action, but let's get the notes out of the way first. So a sticky element is first positioned with the normal flow of the document, kind of like the static type and the relative type. But then it is offset with respect to both its nearest scrolling ancestor and the containing block depending on the left, top, right, bottom properties that you have set. I know this is very hard to understand, but just think of it as it is constrained by its parent block, which may or may not be a position element, by the way, and it is also affected by scrolling in some unique way. What a lot of people say when trying to explain what the sticky position is this: the element is treated as a relative position until it crosses a specified threshold, at which point it is treated as a fixed position. So it's kind of like a hybrid between a relative type and a fixed position type. But to be honest, not really if you go into the fine details of it. But I think it's a good analogy to get your head around it. We'll see examples of it soon. So what do the left, top, right, bottom properties do on the sticky element? They are offsets from both its containing parent block and scrolling ancestor that are used to constrain the sticky element within its parent and scrolling ancestor. The word constraint is the key here. Again, this is a mouthful and very abstract, but it will make more sense once we see it in action, so don't worry. Now, a sticky element without the left, top, right, bottom properties will behave just like a relative type without any of the properties. But again, there's no reason why you would use a sticky type without one of these properties, so let's see this in action. All right, so let's check out the sticky position. Let's give the child to position sticky. Remember what I said? Without using the left, top, right, bottom properties on a sticky, it behaves exactly like a relative position type. So I refresh the page, nothing happened, right? It's still within the normal document flow. I scroll, nothing is happening. Now, the reason why I say relative type and not static type is because it is a positioned element. Meaning, if we go to the grandchild and we now position this absolute and left of 15 pixels, and top of 15 pixels, it will be left and top of 15 pixels with respect to its positioned ancestor, which is child 2, because sticky is a position element. So you see this is a position with respect to child 2. So sticky position without left, top, right, bottom properties behave exactly like the relative type. Again, you will never do it like this. You will always put a constraints of left, top, right, or bottom on this. So I just want to get this out of the way. Let's erase all the positions and the left and top stuff from the grandchild. Go back to our child 2. Now let's see what the sticky does. I'm going to give it a top of 15 pixels for now. And I refresh the page, it seems like nothing happened. I'm scrolling a bit and it just still seems like it's doing the same thing, right? But the interesting happens is, remember what I said, it is constrained by both its parent block, which is the parent in this case, and notice the parent is not a position element, it's a static position, so it is not a position element, but it is constrained by both its parent block and the scrolling ancestor. So what I mean by that is it's constrained by first by this parent div, and also is affected by the scroll. So check this out. We are top constrained by 15 pixels, right? I scroll. The moment the child 2 is 15 pixels from the top, like here, it's stuck in place. It's sticky to the window. Do you see that from the top? But the moment I scroll out of, you see the parent is ending here, right? The moment it hits that, now it just flows out of the way. So it's constrained by both the scrolling ancestor, which is up here, you see that in action up here, and also its parent block, which is down here. So now it scrolls out of the way. So it's pretty interesting. It behaves like a relative type right now, but the moment it reaches a threshold, like the quote said, it acts kind of like a fixed position, and then it's out of the way. Okay, so now a pop quiz. What if we were to put a left of 15 pixels here? What would happen if we put a left of 15 pixels. If you were so used to using absolute position and fixed position, you might think that it's now like 50 pixels from the left. But remember, it doesn't position it like that. It's sticky. It does this weird thing. Let's just see what happens. I refresh the page. It still seems like it's in the same position, does the same thing. But now, what is so different about it? Let me try scrolling to the right now. I scroll right, and now it's sticky to the right by 15 pixels. Okay, so what if instead of the left of 15 pixels, what if I put bottom of 15 pixels? What would this do? So I refresh the page, nothing changed. It's still sticky to the top by 15 pixels, constrained I mean, and it hit the bottom. You might have thought that it would have stopped at this 15 pixels from this one, but it actually didn't. It went to the very end and is out of the way. So it's almost as if it behaves exactly the same as if this bottom 15 pixels didn't exist. So when does this 15 bottom come to play? Now let me show that to you. I'm gonna go to the parent now, just to have more space up here from the top of the window to the parent. I'm gonna give the parent a margin top of, let's say, 1,000 pixels. How about, maybe that's a little too much? Whatever, it's enough. So I'm gonna refresh save and refresh the page. Now it's not loading, so I'm gonna close this and open the preview again. There we go. So right now it is margin top is 1,000 pixels, so we don't see it on the screen. However, the moment I start scrolling, I see child 2 here. What's he doing here? What if we didn't? Let me just show you guys. Let me show it to you first. Do you see now it's constrained by the parent, and the moment it got from the bottom of the scrolling ancestor 15 pixels, it stopped in place until it went to its original spot. Do you see this? Spam. And then as we keep on scrolling, it goes to the 15 pixels from the top, and now it's stuck again. So that's what the bottom does. It constrained it right here. Right here. Let me show that to you. If I get rid of this 15 pixels now, bottom of 15 pixels, I refresh the page. Child 2 is in its normal position, right? And it's only affected when we go to the top, when we go to the top constraint. But when we add the bottom, once it's affected by the constraint of the parent right now, and now it's constrained by the bottom element, the bottom property I mean, and now it's back to normal. So I know this is kind of tricky, but you'll get used to it once you use this a lot. So that was a use case of the sticky position. And I want to show you guys one more example of this. Actually, before we go on to the second example, let me show you guys what happens if I put a sticky to the grandchild 2. So I'm going to make the grandchild position sticky. And I will also have this top of 15 pixels, and we'll just keep it up top of 15 pixels for now. And let's get rid of this bottom one. I also want to get rid of the margin because the margin top 1,000 pixels is kind of ridiculous. I'm going to refresh the page and we're back to normal. Now look very carefully to what happens for the child 2, who is sticky position and top of 15 pixels, and the black grandchild, which is top 15 pixels and sticky. So I scroll. The child 2 now is approaching its constraint. Now it's stuck. And seems like nothing's happening to the grandchild. But if I keep on scrolling now, the child 2 will hit its other constraint of the bottom of this parent block. And it's going to scroll out of view. Now look at what happens once it scrolls out of view. The black one now is constrained by the 50 pixels at the top. Do you see that? Let me show that to you again. My browser's kind of freezing up. There we go, like that, like that. So it's constrained with respect to the child 2 and its nearest closest scrolling ancestor. That's very hard to say. All right, let me show you guys something kind of cool. I have a bunch of divs here, almost identical divs called the parent. And within it, we have the header property h1 and 3 p tags for each of them. 1, 2, 3, 4, 5, 6, all 7 of them. And how I style these, the thing of note is the h1, which each of the parents have, right? They are positioned sticky, and they are sticky from the top of 0. And that is it. So let's see. So every single one of these is 1. There's 2, 3. All these header tags have a sticky of top of 0. So let's see what happens. I can save, not this save. I don't know why it made it that big. Okay, so I'm gonna refresh the page. Okay, you see this one? Now it's sticky top from 0 pixels, so it's stuck there. Now what would happen once this 2 approaches it? Because he's also sticky from the top, right? So the moment we get to it, it shoves it out of the way, and now 2 is stuck. So did 2 really shove 1 out of the way? The answer is no. Why 1 is seemingly being shoved out of the way? Because it's constrained by the parent block, which is the parent class. So the moment the parent class, which ends here in this green line right here, it gets shoved out of the way because it's constrained by its parent. So we see 2, now 2 gets shoved out of the way, and we see 3 and 4 and 5. All right, so let's summarize what we have learned today. So first of all, the position property, it's used to position an element on the document. There's 5 position types. There's the static position type, which is a default. So meaning if you don't put a position type, it will default to the static position type. There is also the relative, the absolute, the fixed, and the sticky. Elements with static type is a non-position element. Other ones are positioned elements. So the relative, absolute, fixed, and stickies are considered positioned elements. Now, the reason why this is important, the reason why this distinction is important is because on positioned elements, you could use the left, top, right, bottom properties and the z-index on it. Also, absolutely positioned elements is positioned with respect to its closest position ancestor. These are the 2 reasons why we make the distinction. Static and relative position types are positioned according to the normal flow of the document, meaning its siblings and its parents know that they're there and they are stacked depending on the normal flow of the document. But the absolute and the fixed position types are removed from the normal document flow. So to the parents or to the siblings, it's as if that they don't even exist. The sticky behaves a little bit different. It is initially within the normal flow of the document, but then when it reaches one of its constraints, it is taken out of the normal flow. And finally, and this is very important and the point of many confusion, the left, top, right, bottom properties behave differently depending on which type you're using. All right, guys, so this was the first part of the CSS Mastery series. We covered the position type. Hopefully you guys like this. I spent a lot of time making this video, and to be honest, I also learned a lot when I was studying up on this video. So hopefully you guys liked it as well. Hopefully you guys have taken something from this video that you could use in your web development. Now, if you guys liked my content, please click like and subscribe below, because again, I'll be releasing, this will be a beginning of a series that I plan on doing in the short-term future. So please stay tuned for that. And in the meanwhile, while I don't really use the position elements, let me show you guys 2 fun projects that I made recently. And the first one is a Pokédex, where we build a Pokédex using the Poké API. And this is purely made with HTML, CSS, and JavaScript. And also, you could check out my Connect 4 game that I made using vanilla JavaScript. So if you guys are interested in these type of videos, please check the description in the links in the description below. And I will see you guys next time. Stay safe during this time and happy coding.